Thank you, Mr. Shuk, and thank you to Italian Embassy and also to my predecessor, all the speakers. They actually quite timely and also make me very excited, from Baker Hughes because we are aligned very much with all the what presented, from the government, from the policy, from the uh, oil companies, and also others, I guess, on providing technology as well. So I would like to bring all the jargon and all the situation that really start with global and then going down to say Indonesia situation, right? Because at the moment, for us in terms of where we are today and what we have, in terms of the facilities, the existing facilities with some flaring and some methane escapes, and then also the measurement, right? This is the situation that we need to deal with and how to reduce the carbon emission from existing facilities that we have today. And then the second one, we will move into the, if we are actually kind of building and or try to develop the resources that still not developed today. So with all the requirement in Indonesia of energy and then also of oil and gas, then we really need to strike and how can we produce more but with less carbon emission or even zero, the facilities and also even the LNG plant. And that is really the combination of the two. Then we can really start to quantify and verify of how much is actually emission that what we have and how much we need to reduce, and then is the technology are available. So the last one that we also looking very strongly is also alternative energy. We are strongly believe that the hydrogen and geothermal will play a big role in the whole energy transition solution that we can offer. So on the first one, I'd like to draw to the digital energy because every efficiency percentage that we can gain, that will be correlate directly to reduction of carbon emission. So in the big picture, I'd like to really draw what we have to offer is from the Baker Hughes C3.ai suite, that this will be enhanced and optimized from the upstream that we have into the midstream and even to the downstream or retails. And then the beauty of this system, we will take any data that existing today from different operators, from different companies, that we will put them in unified virtual data lakes, which is really common and can be utilized across all this portfolio that we have. But then we can also develop, not in series, but if we go directly to the production optimization of the field, predictive maintenance, up to even demand forecasting for refineries, right? And then with this, really the first step that we can do is to increase efficiency in what we have today. And then at the same time, it's also reducing the carbon emission. And then, as all we heard from the previous speakers, it's really what are the specific challenges to the carbon capture? Because carbon captured alone, we believe that from IEA as well, it's around 25% of the total emission that we can actually handle with the CCS. And then everybody actually mentioned, Pa Roberto, and then also said, hey, look, the economics, we need to look at it, right? Where are your assets, the sources, located in comparison to access to the pipeline, and the sinks that it's possible to capture. How big is the sink and how is the integrity of the sink today? Because at the end of the day, the carbon capture is not just straightforward of the opposite of production of gas, right? Especially carbon, it is different gas, and it's typically also can be very corrosive, and then that will impact of what pipeline and what existing infrastructure can be utilized. And then the quite important as well is the execution. We do have plans, we do have thought and what we can do? Are the technology are available? And then can we start, how fast we can start our planning? So again, in these three, I guess we are looking at this as well very closely. And then of course, it's very important, as Pak Fatar and also Pak Tutuka earlier mentioned, is carbon trading pricing policy from the government are really will boost and or will help to support the decision that we need to take all together with the operators. And then on the CCUS, I think it's really important that we have the portfolio, from the feasibility study. We have Gaffney Klein, which is very well known in the industry, and then the IO Consulting, to really try to see what option do you have in surrounding your field, right? If you do have power plant nearby, or even the fertilizer company and cement factories, and it's really then we can come up with a solution not only to oil and gas, but also to other industry in surrounding to us. And then, of course, when we deal with the power plant, then carbon capture is actually one very significant role in there, because it's not cheap. And then the gas we try to capture from the flue gas or the exhaust of the power plant from the coal is around 14%. So it's not a big number as such, and at really almost zero pressures, right? So to capture is really a bit different than separation when CO2 coming from the reservoir. And then once we captured and or separated, of course, depending on how far, and that is on land or offshore, how do we transport those CO2, which is typically when a pipe, it has to be in the supercritical phase that is really easy to flow. And then this we have as well, which is really non-metallic, so that is non-corrosive at all. And then on the smaller size, we have the flexible is in the roll, so it's really quickly when you need to really collect the CO2 to a gathering station or storage before you transport them to the real storage in the reservoir. And of course, the compressor, we have a decade of experience on the specific design, either reciprocal and or really the compressor that's special for injection into the reservoir for the storage. And then, of course, our core business before was well construction, which is really how to design and drill the wells and the reservoir for injection and then for monitoring. And then, of course, closer monitoring, we need to keep the CO2 up to 99 years, right? And how you design the capture or the storage there. And then we put the monitoring, at the reservoir, and then at the cap rock and above the cap rock, and then really away from the wellbore, the injection well. So we will detect any slight possible leaks very early. It's still underground around the reservoir. And then really the enhanced oil recovery by utilizing CO2, it's something already common in the US, in South America. And then we feel that this will have a big opportunity in Indonesia because of the situation. Now, because we do have all this portfolio, the project development, I think that will be part of the whole offering that we can do to help everybody to achieve or building the roadmap to zero emission. Now, I just want to really quickly mention what we have in terms of capturing technology. We are developing our proprietary chilled ammonia process and then a mixed salt process. This is for capturing from the industrial. And the base of solvent is ammonia, which is very common in the industry. And we do have a lot of manufacturing here. And then, of course, the last one that we invest or acquired is actually the compact carbon capture. The biggest thing about this is using the rotating beds to capture, and then we managed to reduce the footprint of the process up to 75% less. So then it can be really hopefully installed in the small kind of area, the existing area. Right? So this is really to support our kind of integration and then providing really a good area for feeding, as depend on how big is the carbon to capture. And then, of course, in the design of the storage, we do have all the processes and then the monitoring. And from Ian, I mentioned that we do use the fiber optic, and we do have both as well, which is the DTS, which is the temperature sensors, and plus the distributed acoustic, which is then it can utilize in microseismic monitoring with the sensor in the well. And that will really helping us to monitor for the whole cycle of the integration. And then the enhanced recovery, as I do mention earlier, in the US, they actually contribute of 6% of 350,000 barrels per day out of the CO2 EOR. Right? And then we are supporting 25 projects at the moment. And in Indonesia, again, with Gundi and or Sukowati, I think it's very close to the pilot. And since we do have a lot of field that already depleted, and maybe that is actually applicable for also the usage of CO2 that's been captured. And then on top of that, we are believe that the technology is still developing, and then one of the quick or accelerated is we do invest and we do work, collaborate, and then on the capture side with many companies here, the Horizon and Electroshi, but also on hydrogen. And with SNAM, with Maria mentioned, we also collaborate with that, and then with Bloom Energy as well. And the latest actually is not here. We are investing in Acuna, and the big deal was we can produce blue hydrogen from natural gas, and with the side of CO2 produced will be in the solid form, so it's no emission, right? So if we do have natural gas produce hydrogen drive the turbine, that we do have 100% fuel hydrogen turbine, then suddenly low and near zero facilities make possible, right? So that is really the last slide from me, and thank you very much for the opportunity. Back to you, Mr. Shu.